Welcome to our channel Maritime TV. Today our topic is about ship refrigeration systems. In this presentation, we will talk about what is ship refrigeration. In introduction, the purpose of ship refrigeration is to maintain cargo, is food, medicine, or chemicals at required temperatures during sea voyage. So this refrigeration works on the principle of vapor compression cycle, whereby refrigerant absorbs and releases heat through phase changes. What's a critical need for refrigeration? Without refrigeration, perishable cargo degrades, costing millions and failing health regulations. Also, key standards with SOLAS and flag state requirements mandates maintain the temperatures for reefer cargo. Also, the heat flow moves from low temperature to high temperature. Now let's see temperature targets for different cargoes or different commodities in a ship. We have chill limits. This range between positive 2 degrees centigrade up to 4 degrees centigrade. So for fish or seafood, minus 18 to minus 25. For ice cream, minus 25 to minus 30. For fruits and vegetables, we have 0 degrees centigrade to positive 13 degrees centigrade. So for pharmaceuticals, it's plus 2 degrees centigrade to plus 8 degrees centigrade. For chemicals, this varies by the type. So this is our complete diagram or circuits which show the refrigeration cycle. So the full system is compressor. You see here this one compressor, condenser. This one is condenser. Dryer, we have dryer here. Siphon, we have siphon glass. TEV, our thermal expansion valve. This one. Also we have evaporator. Also the back to pressure. This is our evaporator. Back to compressor. This is our compressor. Okay. Now let's start component number 1, the compressor. This is the heart of the refrigeration system. The role of compressor is to raise the refrigerant pressure and the temperature from low side to high side. So, main type used is reciprocating, this piston or screw compressor on ships. The compressor section draws in low pressure superheated vapor from evaporator, then discharges it by pushes out high pressure superheated vapor to condenser. So this compressor is driven by electric motor monitored through motor control panel. Also, this compressor is protected by LP cutout for low pressure and HP cutout for high pressure. Also, this compressor is fitted with gauges, is suction pressure gauge and discharge pressure gauge. Discharge for high pressure and suction for low pressure. Also, cooling is motor cooled by suction gas passing over windings. Okay, now component number 2 is condenser. It's a high pressure heat rejection site. This is a place where refrigerant rejects heat. So the role of condenser is to reject heat from refrigerant to seawater. This water condenses to liquid. The type used mainly shell and tube heat exchanger with seawater through tubes. Seawater in. Seawater enters at the bottom. Cooler water first contacts subcooled liquid. So seawater exits at top. Through seawater outlets with thermometer. Also, we have air point. This is air or non-condenser released from top through hood valve. The function is HP, hot vapor enters, then cooled by seawater becomes high pressure liquid. The temperature is the refrigerant condensing temperature is 10 degrees centigrade above seawater temperature. So this pressure is monitored by discharge pressure gauge. This HP cutouts protect this side. So this is the heat rejection process where high pressure vapor enter in condenser, seawater provide cooling, so condensing. This is change, vapor change to liquid, so subcooling. The liquid cooled below saturated temperature, so HP liquid out. Let's see components 3 and 4. This is the receiver and the dryer. It's the receiver and the dryer. It's the receiver for liquid storage and the dryer for filtration. Receiver is the liquid refrigerant storage vessel. This location is after condenser, before dryer, whereby high pressure liquid side. This function acts as a buffer or a saver, ensures steady liquid supply to thermal expansion valve. This capacity holds enough refrigerant for full system charge plus extra. Also, it has sight glass. It's the level indicator, must show liquid, not bubbles. If bubbles means low charge, low refrigerant charge. Also, it has stop valve on inlet and outlets, so you can isolate it for maintenance. This pressure is high pressure side, is 12 bar typical. Also, you have a dryer, this filter dryer. This removes moisture and the contaminants. Location is after receiver, before siphon glass, liquid line. The silica gel or molecular sieve absorbs moisture from refrigerants. So inside have silica gel or molecular sieves which absorb moisture from refrigerants. So I have mesh strainer removes solid particles, scale and debris. So moisture as refrigerants can cause acid, which bring to corrosion. So this causes ice to thermal expansion valve, also to lead to blockage. So siphon glass, this is the sight glass after dryer. These bubbles indicates need to add refrigerant. Also, you have filling connection here. It's a connection point to add refrigerant to the system. This is diagram here. As we explained, this is a compressor. It is the LP cutout, also suction pressure gauge, discharge pressure gauge, and HP cutout. And this is our motor control. Also, this is our thermometer. This is our condenser. This is our badge for air removal. This is seawater inlet. This is seawater outlet. This is the receiver for storage of refrigerant, liquid refrigerant. Also, we have this master solenoid. Also, we have this dryer. As taught here, this is dryer after filtration to remove debris from the refrigerant. Also, we have this filling connection for filling refrigerant. So we have this siphon glass which shows the level of refrigerant. Let's continue. So components 5 and 6 is thermostatic expansion valve and solenoid. This provides position flow control. Start with TEV, thermostatic expansion valve. This is the metering device. It controls the refrigerant flow to evaporator. The thermostatic expansion valve controls the refrigerant flow to evaporator. It has sensing valve 1 and sensing valve 2. On suction line after evaporator, sense superheat of vapor leaving evaporator. Sensing valve number 2, ensure the refrigerant is fully evaporated before entering compressor. This prevents liquid sludge. So action. Valve temperature rise. If valve temperature rise, since valves open, more refrigerant flow, causing more cooling. So when valve temperature falls, valve causes less flow, prevents flooding of the evaporator. Superheat set to maintain 5 to 8 degrees superheats. Ensure 100 vapor at suction. Thermostatic switch is located near evaporator. Starts or stops compressor based on room temperature. Also have a solenoid valve. This is the electrical operated shut-off valve. This location is before thermal expansion valve and liquid line. The room solenoid valve also on each evaporator. It's open when the thermostat calls for cooling is energized electrical, and it closed when room temperature reaches the energized cuts the refrigerant flow. So master solenoid main shut off before dryer, closes when the compressor stops to prevent liquid flood back. So it's safe to prevent liquid refrigerant from migrating to compressor during off cycle. Now see components number 7. This is the evaporator. This is where the cooling actually happens. It is low pressure refrigerant absorbs heat from cargo space, evaporates to vapor. Types define the tube cool assembly with large surface area for heat transfer. This pressure on this side, low pressure side. The refrigerant boils at minus 25 to minus 35 degrees centigrade. This process, liquid refrigerant enters in evaporator, absorb latent heat from air. So the liquid refrigerant boils to vapor. Also there is an airflow. Fan circulates cargo hold air over evaporator fins continuously. This also increases the change phase of this refrigerant vapor. Also have a drip tray. This collects, condensates moisture from air. Drain heater prevents ice blockage. Also have drain heater. This electrical heater and drain pan melts ice to keep drain clear at all times. So you have real room solenoid. Each cargo space has its own solenoid valve, can control independently. What is defrost system? You have time clock. It triggers automatic defrost that set in intervals. For example, every 6 hours. So the first element, electric heater, melts frost from evaporator coils. So first, the build up reduces heat transfer efficiency significantly. The duration is typical 20 to 30 degrees per defrosting cycle. In terms of absorption facts, have refrigerants weighs at LP minus 30 degrees centigrade, absorb 200 kJ/kg, latent heat, air cooled to required temperature, or suction vapor to compress. So let's see safety in the control devices. It's protecting people, cargo, and equipment. Every device in the system has a critical safety or control rule. We have this HP cutout. This trims compressor if discharge pressure exceeds safety limits. That is 18 bar. Manual reset is required. This prevents bursts of HP pipes and condenser. Also have LP control. This stops compressor when suction pressure falls too low, minus 0.5 bar. This prevents deep vacuum or air ingress and motor overload from low density suction gas. We have motor control. This main electrical panel for compressor motor. Control starts with top, overload protection, phase failure, protection, and stardust indication. Thermostatic switch is room thermostat starts compressor when cargo space temperature rises. Stops when set point reached. Each room can have independent control. Half-time clock initiates automatic defrost system at programmable intervals. This prevents excessive frost buildup on evaporator coils, which reduces efficiency. So have room solenoids. See individual solenoid valve by cargo space allows each room to be cooled independently. This prevents overcooling and saves energy. So now let's see the complete refrigeration cycle step by step, tracing the refrigeration part. Number one is compressor. Compressor draws low pressure vapor from evaporator, compresses to high pressure superheated vapor driven by electric motor. Go to condenser. High pressure hot vapor cooled by seawater, condensed to high pressure liquid. Heat rejected overboard through seawater outlet. Also, we have a receiver. The receiver stores HP liquid refrigerants. It acts as a buffer, provides steady flow to the set of system. So we have dryer, siphon. The filter dryer removes moisture and particles. Siphon brush shows liquid states. When no bubbles means system charged correctly. So have solenoid and thermal expansion valve. Master solenoid controls flow. Thermal expansion valve meters exact amount of refrigerant, drops pressure from HP to LP instantly. So you have evaporator, which is low pressure cold liquid, absorb heat from cargo space, boils to vapor at low temperature, returns as LP vapor to compressor. So cycles compressor, condenser, expansion valve, evaporator, then compressor again. Don't forget to subscribe to our channel, Maritime TV. Now let's see troubleshooting quick reference. Its common faults and causes. HP cutout trips. Possible causes: condenser fault, seawater pump fail, overcharged refrigerant, non-condenser, high ambience. LP cutout or trips. Possible causes: low refrigerant charge, thermal expansion valve blockage or fault, solenoid valve stuck or closed, suction line SDR. Room temperature too high. Possible causes: compressor not running, solenoid causes, evaporator iced over, thermal expansion valve stuck or closed, also low refrigerant. It's also frost on suction line. Possible causes: thermal expansion valve overfeeding, flooded evaporator, low superheat setting, also fault sensing valve. So we have oil in system. Possible causes: compressor rings worn, excessive crankcase dilution, oil separate bypass. Bubbles in siphon gas causes low refrigerant charge, so top up at filling connection, dryer partially broken. The key 7 components of ship refrigeration. So this was a summary for our presentation. Compressor raises temperature and the pressure of refrigerant vapor powered by electric motor. Condenser rejects heat to heat to seawater. Condenses HP vapor to HP liquid. So we have receiver. This stores HP liquid refrigerants and ensures steady supply to system. So the dryer, it removes moisture and particles. It protects thermal expansion valve and the compressor. The thermal expansion valve and solenoids controls the refrigerant flow, draws pressure, regulates superheat. Evaporators absorb heat from cargo. LP refrigerant boils, cooling the space. Safety controls have HP and LP cutoffs, thermostat and probe. This protect people and equipment. Remember, the refrigeration cycle is compress, condense, expand, evaporates, and repeats. Don't forget to subscribe to this channel to get more updates. Thank you for watching. Maritime TV. Don't forget to like, subscribe, comment, and share with other groups. Thank you, everyone.